Today, we will answer this geometry challenge coming from one of our followers. And the question goes like this. Given this right triangle ABC, the length of side AB is 3, this AE is also 3, and this EC is 1 unit. Now, let's draw a circle that passed through the point A and E and tangent to segment BC. And let's call this circle as circle O. And also, the point of tangency as point D, and the intersection of this circle to side AB, let's call this as point F. Now, the question is, what is the radius of this circle O? So, pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the answer is 10 minus 2 times square root of 7 divided by 3. This is the length of the radius of this circle O. Now, of course, the question is, how do we get this result? And here's our solution. In order to find the length of this radius R, what we're going to do is to find first the length of this segment BC. And to do that, we will use what we call the Pythagorean theorem. So we have BC raised to the power of 2 plus AB raised to the power of 2 equals AC raised to the power of 2. Substitute all the given values. We have BC squared plus 3 squared equals 4 squared. Simplify and find the value of BC, and we get that the length of BC or segment BC is simply equal to square root of 7. Aside from the length of segment BC, we also need the length of this segment DC. So how do we get this length DC? What we're going to do is to use the power of a point, or simply what we call the secant tangent rule. If a secant and tangent are drawn to a circle from the same external point, the product of the lengths of the secant and its external segment equals the square of the length of the tangent segment. In this figure, we can say that segment PA times segment PB equals segment PC raised to the power of 2. We will apply this concept to find the length of this segment BC. So we have AC multiplied by EC equals the length of DC raised to the power of 2. We know AC, this is 4, EC is 1, so we have 4 times 1 equals DC raised to the power of 2. Get the value of DC, and sure enough, we get that the length of DC simply equal to 2 units. From here, we also need the length of this segment FB. So how do we get this length FB? So again, we will use this concept, but before that, let's call this segment FB as X. Now, using again this concept, the power of a point, we have AB times FB equals BD raised to the power of 2. We know AB, this is just 3, and this FB, we know this is X. Now, BD is just the difference of square root of 7 and 2. So we have square root of 7 minus 2 units, or raised to the power of 2. Simplify, we have 3x equals 7 minus 4 times square root of 7 plus 4. We have the square of square root of 7 minus 2. Now, combine like terms and simplify. We have 3x equals 11 minus 4 times square root of 7. Divide both sides by 3. We get that x, or the length of this segment FB, as 11 minus 4 times square root of 7 divided by 3. This is the side length of this segment B. Now, let's focus to the question. What we need is to find the radius of the circle O. So, to find the length of the radius, what we're going to do is to connect the point of tangency D and the center O. Again, this is just the length of our radius of the circle. And we know this OD is perpendicular to segment BC. We need one more concept to find the length of this radius R. And that concept is what we call the perpendicular bisector of the chord theorem. And here it is. It states that the line drawn from the center of the circle to the chord is the perpendicular bisector of the chord. So, sorry for the wrong spelling. This is just CHORD. So, if we draw a segment that is perpendicular to segment AF, Then this point of intersection bisect this segment AF. And now, we can now find the length of this radius R. This is just the sum of half of this segment AF plus the length of this segment FB. The main reason for this result is because we have here a small rectangle. If we find the value of AF, we know the value of FB. We have 11 minus 4 times square root of 7 over 3. So if we find the length of this segment AF, then we're done. To find the length of this segment AF, we know that AF plus FB equals 3, or this segment AB. We know the length of AB. This is just 11 minus 4 times square root of 7 divided by 3. Subtract this both sides. We have AF equals 3 minus 11 minus 4 times square root of 7 divided by 3. Simplify, we get that AF equals 4 times square root of 7 minus 2 all over 3. We have the length of AF and we also have the length of FB. We now get the length of the radius of the circle O. We now know AF, this is 4 times square root of 7 minus 2 all over 3. We know FB is 11 minus 4 times square root of 7 divided by 3. Simplify, the first term, we have a denominator of 6. Therefore, we need to multiply the second term by 2 divided by 2. If we do that, we get this equation for R. Now, combine like terms, we get that R simply equal to 20 minus 4 times square root of 7 all over 6. And if we simplify more, divide the numerator and the denominator by 2, we get the desired result as 10 minus 2 times square root of 7 all over 3. And that is the length of the radius of this circle O. Therefore, given this figure, then the length of the radius of the circle O simply equal to 10 minus 2 times root 7 all over 3. And as always, we are done.